Hello everyone, I'm Shanghao, and in this video I'm going to walk through my data science project I've done in the DS4100s. The main goal of this project is to predict property values for different US counties by using demographic data. And I'm going to follow CRIP's DM module in this project. The first step is business understanding. Property values are mainly driven by supply and demand, like populations, availability of properties, the size of an area, etc. And there's other factor that affects property values too, like racial composition of a county, job opportunities, education, etc. A lot of this factor might be correlated to each other, so if we are building a linear regression model, we need to avoid to use two parameters that are strongly correlated to each other. Now, let's take a look at what kind of data I'm going to use in this project. I have two main data sets. One is about the demographic data by counties, and the other is the property value data by county. Let me go to RStudio and load those data into a data frame. Now, I realize that one data frame is using the state's full name, but the other data frame is using the state's abbreviations. So I found a list of US state in Wikipedia, and it has all the information I need. So I scraped the table from this HTML file, and then using the information in it to merge my original datasets. Now I have one single table. But if we take a look at the full data frame, we can see that some location does not match up correctly. We can see in one data frame, it always used the words parish, while the other data frames never use the word parish. Now I'll remove the word parish from the data frames and try to match them up again. After that, there's 4 counties with demographic data that miss a property value. I use KNN algorithm based on the population of each county. The algorithm gives me 4 outputs, and after searching them on the internet, we find out although the names are different, they are representing the same counties. Those mismatch in county name is caused by a name change. All the mismatches are resolved, and let's take a look at if there's any missing values. There's 3 missing values in this data frame, and since the amount of NA is small, we can impute them. I used the mice package for the imputations, and then saved the imputed data frame. Now, I'll try to understand all different variables in datasets. We can see there's 2 population variables, one from each of the data frame before merging. It turns out that the population from the demographic data frame is in average higher than the population from the property data frame. This might be caused that the population from the demographic data frame is newer than the population from the property data frame. If we plot the population against the property values and area, we can see the population data is directly related to the values, but the area is inversely proportional to the value. And if we compare the property values and the change in populations, we can see there's a rather strong correlation between them. Then, let's move on to other data in the datasets. There are 5 variables that might indicate poverty, and let's see if they're correlated to each other. Unsurprisingly, there's a strong positive correlation between income and income per capita, and there's a rather strong negative correlation between income and poverty, including child poverty. Unemployment seems to have stronger correlation to poverty and child poverty. Then, let's try to understand how race compositions affect the property values. In this preliminary linear regression model, we can see how racial compositions affect property values. The dataset also provides the type of occupation as well as the method of transportation in each county. However, after doing some basic analysis, those data are not very interesting and will be omitted in this presentation for the sake of time. Now, we'll move on to the data preparation phase in the CRIP's DM module. In this phase, I'll create some derived features as well as revisiting population and property values for the reason that we'll review later. First, we'll create a derived feature called % citizens. It's natural to think that immigration might influence the property price. I find out that if there's more citizens in a county, the property price might be higher. Then, let's take a look at the population density, which is the total population divided by the area of the county. However, this new derived feature is not helping, as the total population is a better indicator for the property value in each county. Then, I try to measure the diversity in each county and see if it helped me to predict property values in each counties. I built a way to measure diversity, and if we take a look at the diversity index of all counties, we might see there's a clustering. So I use a k-mean algorithm to detect this clustering. I use k as 2 first, and then k as 3 as a comparison, and see which one gives me better results. If we do a t-test among each diversity group, we can see there's a significant difference in property values for different diversity groups. In particular, the group with higher diversity will have a higher property values. But if we build some simple regression model, the result is opposite. This can be explained since the property value as well as the total population is not normal distribution. That is the reason why we need to revisit population as well as property values. If we plot the population, this is not a normal distribution. What if we take the natural log of population? The log value of total population is normally distributed. Then, the log scale of the property value must be normally distributed as well. After converting population and property value into log scale, we do the diversity grouped linear regression model again. The R-square value is quite small for both of the model, so we are not going to use the diversity groups in the final modeling. Now, we'll move on to the modeling phase. I'll break up the complete datasets into the training datasets and validation datasets randomly. I'll build 4 linear regression models first, all of which will use the total population, the racial compositions, the percent citizens, and the area of a county. For the first model, I'll also use income and unemployment. For the second model, I'll use income per capita and unemployment. For the third model, I'll use poverty. For the fourth model, I'll use child poverty. And I'll use a backward elimination process to eliminate all the unnecessary parameters. I'll compare the summary of the linear regression model, the MAT, the MSE, a scatter plot of how accurate is the prediction against its property values, as well as a histogram of the accuracy of a prediction. From all those information, I can conclude the second model, the one that uses income per capita, has the best performance. However, I also noticed that the higher is the property value, the less accurate is the prediction. So I remove all the counties that has very high property values so that my model will have a better predictions on majority of the county instead of the big cities. After removing all those counties, I'll build 4 new models with the same parameters. Now we have 8 models in total. To evaluate the fit of these models, we need to use our validating datasets. I calculate the prediction interval of these validating data frames for all of these 8 models. Then, I count the interval to correctly predict the actual value, overestimate or underestimate. I'll also compare the size of prediction interval for each model, as well as take a look at the prediction error. After doing multiple comparisons, I find out that Model 2 has the best performance. Although it's not the most accurate in terms of prediction interval, it has the smallest MAT and the smallest MSE. Removing the big cities when we're building a model increased the accuracy of the prediction interval, but it also increased our MSE. After all, the final models uses the log scale of total populations, percent Hispanics, percent Pacific, percent citizens, income per capita, and the area of the county to predict the property value of the county. Thank you for watching.